Friends, welcome back to my new video. I am Tarun Kumar GS, studying my BE in Sri Venkateshwara College of Engineering. Currently, I am studying in second semester. My section is DEVO. My course is Artificial Intelligence, and my USN is 1BE23CA048. And today's subject is Introduction to Civil Engineering. Its subject code is BESCK2041. Today's my topic is what is centroid in civil engineering? A centroid is a geometric center of a geometrical object. A one-dimensional curve, a two-dimensional area, or a three-dimensional volume. Centroids are useful for many situations in statics and subsequent courses, including the analysis of distributed forces, beam bending, and the shift torsion. To find the centroid of a given figure, we should follow certain tips and certain rules. The first rule to find the centroid of the given figure is the centroid is always lies on the symmetrical axis. We should first find whether the figure is symmetrical along any x-axis or a y-axis. Identify the symmetrical axis. If any, choose them as the reference axis. If no symmetrical axis is available, choose the left and bottom corner of the given figure as origin so that the center figure lies in the first quadrant to avoid the negative centroid values. If there is no any symmetrical figure, we should choose its bottom as a origin so that that figure will lies in the first quadrant. It is because of to avoid the negative values. Subdivide the given figure into known geometrical shapes and identify their individual centroid by denoting them with C, whether I is the number of subdivided shapes. Divide the given figure into the sub figures and find their centroid. It will become easy to find the center of that given figure. In the table, we must enter the component, area, centroidal distance from y-axis, centroidal distance from x-axis, ax and ay. Coming towards the fifth point, indicate the calculations like enter the x into y values for area and then enter the result. Do not enter the result directly. For the centroidal distance, enter the equation with the substituted numerical values like 3 plus 4 into 5 divided by 3 pi etc. The areas are negative if halo and the centroid values are negative if they are below the x-axis or left of the y-axis. Coming toward the sixth point, compute the centroidal values of x bar is equals to sigma ax divided by sigma a. To find the x bar, the formula is sigma ax divided by sigma a, and to find the y bar, the formula is sigma ay divided by sigma a. Coming towards the seventh point, the centroidal value of the triangle is always 1/3 of the length from the base and 2/3 the height from the apex. Coming towards the eighth point, the centroidal values of a semicircle is always measured as 4 r by 3 pi from the base of the semicircle, normal to base or along the symmetrical axis. These are the points or tips to solve the centroidal problems. Coming towards next, centroids for some important geometrical figures. First figure is a rectangle. To find the we know the area of the rectangle, it is b into d, that is breadth into d. To find the x bar, we should look from the y-axis. From y-axis, we should take b by 2, means breadth divided by 2 to find the x bar. And to find the y bar, we must take d divided by 2, that is depth divided by 2. As it is same for triangle, to find the area, half into base into height or half into base into depth. To find the x bar, we should take from the y-axis, that is base divided by 2. To find the y bar, we should take 1/3 into height or the depth. To find the right angle triangle, the area is half into base into height. and to find the x bar, that is 1 by 3 into b. To find the y bar, that is 1 by 3 into height or the depth. To find the area of the circle, that is pi r square, and to find the x bar is, that x bar is equals to r, means the radius of a given circle. The radius is always the half of the diameter. To find the y bar, it is also r. To find the area of a semicircle, that is pi r square divided by 2, and to find the x bar, that is d divided by 2, that is depth divided by 2. To find the y bar, we should find 4r into 3 pi. R is nothing but radius. This is all the things we should use to find the centroid of some important geometrical figures. Next, coming to my problem, determine the position of the centroid for the lamina with a circle cut off shows in the figure. So we should find the centroid of the given figure. So first we must check whether the given figure is symmetric along x-axis or y-axis. So that given figure is not a symmetric, so that we have to find all the components and x and y axis for this question. First we'll divide this figure into a different parts. Let us divide into one rectangle, one triangle, one semicircle and a circle. First let us find the centroid of a rectangle. So the area first is component. Let us take a rectangle as 1, and area, to find the area of the rectangle is b into d, as we read there, base into depth. Base is nothing but 120 into depth is 100. So total it is 120 into 100 is equals to 12000, means 12,000. To find the x-axis, as we read in this, that is b divided by 2, that is nothing but base divided by 2. The base is nothing but 120 divided by 2 is equals to 60. To find y, that is d by 2. D is nothing but 100. 100 divided by 2 is equals to 50. A into x, 12,000 into 60 is nothing but 7,20,000. And a into y, 12,000 into 50, nothing but 6 lakhs. Next we take on second component as a triangle. To find the area of the triangle, that is half into base into height, that half into base into height, that is 1 divided by 2 into its base is 120, as same as base of the rectangle, into its height is as given 60. So calculating that, we will get 3600. To find the x, as we read here, for the triangle it is b by 2, means base divided by 2. It is 1 by 3 into 120 is equals to 40. Coming towards the y-axis, it is 100 plus 1 by 3 into 60 is equals to, why we get 100, means it is from x-axis it is 100 meter above, so we consider 100 plus 1 by 3 into 60, it is 120. Ax is nothing but a into x, it is 1,44,000, and a into y is 4,32,000. Coming towards the semicircle, that is pi, that to find the area of the semicircle, that is pi r square divided by 2. Coming to the pi, as it take as it is the pi into the radius of this semicircle is 50. So 50 square divided by 2, that is 3926.991. And to find the x-axis, as we read here, we should take d divided by 2, as we know 120 plus, because to find x-axis we should take from y-axis. The distance from y-axis to the semicircle is 120 plus 4 into radius divided by 3 pi, that is 141.22. To find y, we can take from x-axis, so it is 100 divided by 2, that is 50. Ax is 554.573.6, and ay is 196, 349.6. And let us take a circle. we should to find the centroid of this given figure, we should subtract a circle in this figure. So it is minus pi into r square. R radius is nothing but 20 in the circle. So pi into 20 square is nothing but minus 1256.637. That is r is obviously for the circle it is as we see here radius, and it is 60. The y is 100 divided by 2, that is 50. The ax is a into x minus 1256.637 into 60, that is minus 57398.22. To find ay, that is minus 1256.637 into 50 is equals to minus 62.831.9. And we should find the sigma of area, that is 18270.354, and we should find the sigma of EAX, that is 1343175.4, and we should find the sigma of AY, that is 1165.517. So to find the x bar, as we know AX divided by sigma A, we should take AX value of in numerator and sigma A value in the denominator, and after dividing we will get 73.517. And to find the y bar, the formula is sigma AY divided by sigma A. We should take sigma AY value in the numerator and sigma A value in the denominator, as we will get 63.793 mm. This is the centroid of the given figure. Thanks for watching my video. Let's meet in the next video with a new topic.